Unit 7 says diagram 2 shows the apparatus setup to determine the empirical formula of magnesium oxide. So this experiment is from Form 4 Chapter 3, obviously. Okay, so for Chapter 3, you got two main experiments you have to know. Number one is this one. Okay, Mg react with oxygen to become magnesium oxide. But first of all, okay, there are some precautions you have to know when you burn this magnesium ribbon. First of all, as you know that magnesium ribbon, before even you put into the crucible, you have to use sandpaper to rub off the oxide layer. Okay, then after you put inside, then you light up the Bunsen burner. When it started to burn, you have to use the lid to close the crucible. Okay, just to prevent the white film going up. Because the white film is the MgO we are talking about. Okay, because the result, very simple, you want to get MgO, magnesium oxide. You have to turn Mg become MgO. So how do you go at the back? Because you have to make magnesium react with oxygen. Where does oxygen come from? Come from the surrounding. Yeah. You cannot just close the entire experiment. You have to leave it slightly so that you can let the oxygen enter so that it can react with magnesium ribbon. So question asks, when carry out this experiment, why does the crucible lid need to be opened once in a while? Open, even though I said just now, you need to close to prevent the MgO, the white film of MgO escaping. But at the same time, you have to open because so that you allow the oxygen to enter so that it can react with magnesium. This is very important because if you just close the whole time, no oxygen can enter, then Mg cannot become MgO. Okay, this is key. If the question asks, why you have to use the lid to close back again, close up the crucible again, then you can answer to prevent the white film of MgO escaping. Question also asks the chemical equation. Chemical equation, look carefully. So Mg, many students forget, Mg plus oxygen. Oxygen is not only O. You have to write O2. This is the reactants. Then arrow, the product is MgO. Because Mg is 2 plus, O is 2 minus. Then 2 plus 2 minus, the charge just cancel off. So it becomes MgO. Then it's not finished yet because this contain around 2 marks, meaning you have to balance the equation. So balance as the left side got 2, O. So the right side only got 1 O, have to multiply 2. Now, Mg got 2, multiply 2 at the front also. This only contain 2 marks. If no balance, it contains 0 mark. The result of the experiment is shown in table 2. Based on the result, calculate the mass of magnesium and oxygen. So this one, if you see this kind of table, you will know how to calculate. First of all, how do we calculate? The mass of magnesium. Okay, the first, okay, let's say you got 3 parts. Okay, you have to measure the mass for 3 times during the experiment. Before you put magnesium inside into the crucible, you also have to measure first. Empty crucible. Then after that, after you put magnesium into the crucible, before burning, you have to put the magnesium also. After burning, which become MgO, also have to measure again. So if you want to get the mass of magnesium, very simple. Just use 2 minus 1. Mass of magnesium, 2 minus 1. Okay, because crucible minus crucible, lid minus lid, then you will get your magnesium punya mass. Then, which is, you use 20 8.75 minus 26.35, then you get 2.4 gram. This is for magnesium. For oxygen, we have to use the 3 minus 2 in this case. Again, I'll show you. Crucible minus crucible, lead minus lead, magnesium minus magnesium. Then now you get the oxygen. So 30.35 minus 28.75, you get 1.6 gram. Let's move on. Calculate the number of moles of magnesium and oxygen. Now, according to the mass that you got just now, magnesium is 2.4 gram, oxygen is 1.6 gram. So what formula do you use? How do you find number of mole? Actually, this one is similar when asked you to find the empirical formula. If there's only one question where they straight away ask you to find number of mole, not number of mole, but the empirical formula of MgO, then you can just draw a table. Contain normally 3 marks. Draw a table. First column is element, unsur. Second column is write down the mass given, the GSIM given. Third, find number of mole, bilangan mole. Fourth, find the simplest ratio of mole. Okay, that's it lah. Normally, you got this 4. Okay, you got number 5. If the simplest mole ratio doesn't get the whole number, then you got 5. The 5th column trying to make it whole number. Okay, so how do we get number of mole? So bilangan mole, there's a formula here. Bilangan mole equals to GSIM divided by GSIM molar. Or in English is number of mole equals to mass over molar mass. So if they ask you to find number of mole for each magnesium and oxygen, so in this case, use mass over molar mass. Just now, we already got the mass, which is 2.4 gram. The molar mass of Mg is 24. Just divide, which you will get 0.1 mole. Not yet, be careful. That's why in exam, doesn't matter, you always read the questions. Okay. After you do one part, you read the question again. Make sure you don't miss anything. Second, do the same thing for O. Same formula. But mass of oxygen just now I got 1.6 gram. So I will just divide off. Okay, because the RAM of oxygen is 16. So divide, I will also get 0.1. Meaning, very simple, it means isn't the ratio of Mg to O 0.1 to 0.1, isn't it 1 to 1? So that's why the third question they ask, what is the empirical formula? Straight right, MgO. How do we ensure all magnesium has reacted completely? This one, okay, I tell you now that actually after burning, right, you have to check, let's say, okay, this one is on my side. You see, 26.35, 28.75, 30.35. Now, the third one, right, is after you finish burning, then you measure the mass. You will get 30.35, right? So, now, it's not that you can straight away stop, It's, you have to make sure you measure again. You have to hit again. Okay, you have to repeat again. It means, normally, this experiment, you have to do 3 steps, right? The main 3 steps is, after you put your magnesium inside, right, you open the fire, right? Open fire means you hit the magnesium. After you hit the magnesium, then after finish burning, you off the fire, right? Then you let it cool down. After cooling down, then you measure the mass. You weight the crucible that containing MgO. Now, this one is the final one, right? So what is, how do you know it's final one? How do you double confirm it? To make sure this is final one, that's why you have to do the 3 steps again. Heating, cooling, weighing. just to be make sure all the magnesium has completely reacted, has 100% become MgO, from Mg become MgO. So it's like you have to repeat heating, cooling, weighing. You weigh again. This, let's say the first time I got 30.35. If the second time I repeat those three steps, then I measure again the mass. If I also got 30.35, it means the experiment is confirmed is finished. Finished means completed. If let's say your mass increase again, become like, let's say, like, I don't know, 30.75, maybe 30.85. Now, if you see this situation, it means not all the Mg become MgO yet. It means maybe like 95%. There are maybe like 5%, 10% still haven't become MgO. So yeah, you have to repeat again those three processes until you get the constant mass. And then only you can confirm all Mg become MgO. This step is to ensure all the magnesium has completely reacted. Okay, so yes, heating, cooling, weighing processes repeated until a constant mass. Constant mass means means you won't see the changes anymore. Normally you see increment. Oh, notice from 28.75, you hit until increase 29, 30 like that. Increase. So why is it increase? Increase because Mg, of course, is lighter than MgO, right? Because now the oxygen has entered. So that's why it should be slightly heavier. Yes. So these are the questions that we'll be asking in exam if they come out MgO experiment.